Hello, I'm here to talk about the multi-axis race car simulator capstone project. This was a capstone project done in collaborations with the Mines Mechanical Engineering Department and the Automotive Track, as well as the Formula SAE team here at Mines. This capstone design project was a legacy project, meaning that a previous design team had worked on it for their capstone project. Their main goal was to get the simulator functioning, which they were able to accomplish. They then tasked us with implementing a mechanical e-stop, making the simulator more ergonomically adjustable, as well as increasing the immersion. You can see here some of the initial problems with the sim. The seat, the pedals, and the steering wheel are not adjustable, so it's really hard to, if you're very tall or very short, to drive the simulator. You are sat very close to the steering wheel, so your arms are kind of crunched up, and the pedals are very awkward to press. You can also see there's no VR at this point, and there's no haptic feedback or any other sort of immersion other than the movement of the simulator itself. Our biggest priority for this project was the implementation of the emergency stop. In order to do this, we were in constant communication with our client, with our advisors. We went through several iterations before we landed on the final design, which you can see in the video here. You can see there it is mechanical. It cuts all power to the sim and drains all the air in the main piston. In addition to that, we also added these electrical boxes, allowing everything like the computer, the haptic reactors, the steering wheel, the pedals to be plugged in internally to the sim, and then that can then be plugged. The sim can then be plugged in separately, just one cord. It can also be controlled by the switch you see at the bottom of that picture. Our goal for the ergonomics was to make the simulator accommodate the 5th percentile female to the 95th percentile male. This is a common Formula SAE ergonomic requirement, and this is what we based our subsystem on. So we can see here we purchased a simulator seat with adjustable rails. We also designed pedals. We inverted the pedals because we found out through testing that it was much more comfortable to press the pedals when they were upside down versus how they were initially mounted on the base of the simulator. We also purchased go-kart rails and implemented them into this pedal box. And as you can see there, we have the steering wheel, which can be adjusted as well if people have longer or shorter arms. In an effort to make our simulator more accessible to as many people as possible, we also implemented this new truck bay opening to allow more people to get in more comfortably and not have to kind of climb and support their own weight when getting into the cockpit. We called it a truck bay because it opens similar to the hood of a semi truck, and we also implemented a door so people weren't climbing over the chassis itself. Like I mentioned in the beginning, immersion was one of the big things our clients wanted us to improve upon. In order to do this, we first purchased a VR headset for the simulator. There was a previous one that the previous team was using, but it was about a borrowed headset from the civil engineering department. The one that we have will stay with the sim and can be used by anyone who wants to use it. We also found haptic reactors for the pedals and the seats. These allow you to feel ABS braking when you lock up brakes and the changes in surface. So if you're driving on the pavement or over rumble strips, on the gravel or the grass, you'll be able to feel that in both the pedals and the seat. Here you can see our final design. We have videos of both someone getting in and out of the sim with the door and the truck bay opening. You can see here how simple and intuitive it is to get in and out of. And when we zoom in here, you will see both the adjustable handles for the seat and the pedals. Once again, you can see getting in and adjusting everything is very quick. It can all be done from the cockpit by one person. And once again, it accommodates for the 5th percentile female to the 95th percentile male. So a vast majority of the people of the population can drive the sim and be comfortable in it. You can see here a video of one of our teammates driving it. We also implemented this new monitor to give the person a wider range a wider field of view, and just to make it as immersive as possible for those who did not want to use VR. Finally, we can see a comparison from the sim when our team first inherited it to the final product that we delivered in May. You can see there's a much more comfortable seat. The VR obviously is a massive improvement. We also see that they are further from the steering wheel, making it more realistic to a real car, and they can press the pedals. They're covered, but they can press the pedals in a much easier, more natural fashion. Thank you for watching the video, and a huge thank you to our clients Adam Duran and Henry Brindle, as well as our project advisors Greg Proul and Dr. Paulina Brodsky.